like with the they show the toxicity of the plants. So these are some results. How is the control plant to which we have one exposure to the plant system, one input and final input. How to because of that condition of the super. These are some other data. And what are the conclusion of the system? Let's get that final toxic effect of super and this involves when you properly understand the system first electron transfer and then so if any kind of particle then the system is not make the food and if you not able to make the food, how do you get this particle? That's why the figure of the particle we are moving at the top. Now come to the second that how can we control the nanoparticle in the toxicity in the plants. We have reported copper and silver nanoparticles, they are toxic for at a certain doses for the plant system. And now a big question before us that how we can control, because if we compare from the bulk material to the nanoparticle, they are more efficacious as compared to the bulk material and even in the small amount. Okay? So this is a big issue that if the nanoparticle starts going toxicity, then how do we compare, then how do we control the toxicity of the plant. So we all know that we have some phytohormones, some synthetic molecules, they are to protect the plant system because we have previously we have checked against the honey. So this is that we have conducted on the isotopes safety, which has been published in by 2017, that nitric oxide indicates even nanoparticle induced phytotoxicity 5%. Means when we apply the nitric oxide, what is nitric oxide? Nitric oxide is a gaseous molecule which we generally give in the form of SNP, sodium nitrochloride to the plants, and it can easily control the silver nanoparticle induced toxicity isotopes. So through this way we can control the plant. We can control the. These are some results. We can clearly see that when you apply SNP, sodium nitroxide, means nitric oxide in the form of SNP, we can easily control the different parameters and the toxicity of the plant. These are some data. And these are some anatomical structure. We have also cut the section and see that where these nanoparticles they are damaging the plant tissues. So we can see that how these are damaging the epithelial cell and the cortex and the chlorophyll. You can see that the damage of the chlorophyll. So it is a main component of photosynthesis. So we can see that how we, as my previous report information when you apply nanoparticle can damage the photosynthesis. So the similar kind of things we have also studied, and this is has been published in plant physiology and IPC. So this is the main conclusion. This has been confirmed that phytotoxicity of 1,000 micromole and 2,000 on each region. When we apply the 1,000 3,000 millimole, so it stores the toxicity isotopes. But when we apply the sodium nitrochloride gaseous molecule on very less amount, 10 micromole, even 100 micromole, it is able to control the toxicity of the silver nanoparticle. This is the first study we published. The second study which we published in the plant science, nitric oxide indicates zinc oxide nanoparticle. Beneficial agent required for not only for the plant system but also for the human being. But if we increase the concentration of any material, it will be toxic for the human beings as well as the plant system. So when we give the excess amount of zinc oxide nanoparticle, it starts with the toxicity. So we have also applied the same nitric oxide against the plant system, and we have found that nitric oxide again very much useful for the beneficial control the toxicity of the nitric zinc oxide nanoparticle in the plant system, weak plant. right? So these are some results can see, and these are some key findings that sodium hydroxide SNPR donor supplementation partially increase the given reduce the particle toxicity through the modulation of activity. Given gene accumulate a similar function of acid, as called glutathione cycle. And through this way, they are easily managed. These are some data of the results which is published in the content cards. So, what is the conclusion of the this study? The result of the study shows that there are two ways through which anode regulates gene process. This is the two mechanisms. First, anode decrease the accumulation of excess gene in xylem and phloem cells, which result in laser generation of oxidative stress as indicated by lower amount of NO. Second, nitric oxide triggers up regulation of endoretic acid cycle enzyme and is associated with metabolites which provide better protection to beats in the contagion of oxygen. So these are some main conclusions of it. This is another study which is published in the Journal of Hazardous Materials in 2021. Hydrogen under 5 the beneficial silicon effect against copper oxide and we know that silicon is a beneficial element. So what happens when we apply silicon as well as the sodium hydroxide? What happens? Both are important to control the copper induced hydroxide. So this study is published in the Hazardous Materials, which is very important for the factor. So in which we have this is the overall experimental setup of our study, and here you can see that this is the control plant, this is the silicon, this we have silicon, this is NaCl. This is a sodium nitroxide donor we are providing. Here you can see that all the growth of all these plants are much high. Here we can see that this is the silicon. And NaCl, this is the combination with the copper oxide nanoparticle, and here we can see that how plant growth means overall the growth of the plant is declining. This significant. These are some results of this study, and that's why this is published in a very high journal. So here these are some results. We have stated we have histochemistry analysis. We have analyzed through some dyes and how the oxidative stress they are the qualitative and the quantitative analysis. So here are some pictures. You can see that the when we apply 100 micromolar copper oxide in a particle, you can see that highest intensity of the here because of the oxidative production. These are basically they are the oxidative stress marker. When we stain with this dye, it will clearly show that which material the oxidative stress. Here we can these are control. We cannot see here how much of intensity, but here we have start staining. We can see that all these are the overexpression of oxidative. So these are some findings of my study. These are some antioxidant enzyme activities we have reported, and I will come at the overall mechanism. Here you can see this is the overall mechanism. When we apply the micromolar copper oxide particle and NaCl and the silicon. So what? So palliate the photosynthesis damage, increase ascorbate glutathione cycle system, increase acyl transportation, reduce oxidative stress damage, and increase the anode content. When we apply copper oxide nanoparticle, when we apply silicon and stress against the copper oxide. So overall, silicon, the combination of hydrogen sulfide and silicon may easily mitigate the copper toxicity of in the rice. So this is the report which published in the rice. So conclusion we have already discussed. So now next, this is again published another study which we have conducted on the silicon and along with the plant growth promoting bacteria. I hope you are aware about what are the plant growth promoting bacteria, PGPRs. So we have made the consortia along with the silica and the plant growth promoting bacteria against the silver oxide nanoparticle. Because in my previous slide I have only discussed with all of you that silicon nanoparticle are very toxic for the plant system. We have checked through classical agency that if we apply the rhizobacteria along with the silicon, because when we apply, somebody can ask me that if you are suggesting that silica is very beneficial, but if you will apply at the field level, what is the response of the plant growth promoting bacteria? Because we all know that plant growth promoting bacteria, they are very essential for the plant growth and development as well as the yield, maintain the quality and quantity. So what are the impact on the plant growth promoting bacteria? That's why we have isolated some plant growth bacteria and we have made a consortia with silicon and we have checked what is the response of silica nanoparticle. And then we have applied it in the classical agency, and this study has been published in the Journal of Analysis and we have found the interesting results. It's very difficult to explain. I will not understand, but I just kind of in layman language that how the root hairs, and other parameters, root hairs, they are influenced very much because of the application of the silica nanoparticle as well as the silicon as well as the PGR. So this can also control. Here again, some parameters we have analyzed about the oxidative. Because oxidative, why we analyze the oxidative stress? Because oxidative stress is basically responsible to decline the growth and development of the plants. Oxidative stress, just like as a fever. If we have any infection, any kind of infection in our body, we feel fever. Generally, we notice that this is very harmful if we are suffering from fever. But fever is a very important. Because through this way only doctor can easily identify that this particular person is suffering from any kind of internal infection. So oxidative stress is only a kind of fever of the plant. If any plant is will feel any kind of stress, internal stress, so the oxidative stress level, MDA, SOR, H2O2 level will always. It will never decrease, right? So we plant sciences generally consider this oxidative stress is like a fever of our body. If it is, we feel that it's a very high level, we can easily identify that plant is suffering from any kind of stress, whether it may be biological or biological. In each kind of stress plant, the level of oxidative stress will always be much high. So we measure this oxidative stress and we can easily say that plant is suffering from the any kind of right. These are some other parameters which we have analyzed and scaled with the plants, and here you can see that what is the difference between the PGPR efficiency cost and silicon particles. So these are some results which are published in the Journal of Analysis. So overall, the gist of this study is to that when we make this is the analysis. The key findings. So what are the main conclusion is this is the mechanism which we have derived. We have published in the journal. What kind of components they are involved to manage the stress caused by the silver nanoparticle, and how these are PGPRs and silicon they are helping to protect the plant cell. So this is the overall mechanism. First hypothesis of silicon and plant growth rhizobacteria with prevention of stress means silver nanoparticle means PGPR. The consortia of PGPR and silicon is very much effective against the silver nanoparticle. So through this way we can control the plant system. This is the conclusion which I have discussed. So this is the another study. Endogenous immunity is the nitric oxide are required for the calcium mediated elevation of copper oxide nanoparticle toxicity speeds. So in this study, this is from this plant here, and this is also. So in this study, we have applied calcium against copper oxide nanoparticle, and we have analyzed that how indoor acid oxide and nitric oxide. Endogenous nitric oxide and endogenous indoor acid, how they are responsible and they have provided great support to the calcium against the again the copper nanoparticle to manage the to manage the copper oxide nanoparticle toxicity in big seed. And this study is also a very beautiful we have conducted, and we have found some single kind of results related to oxidative stress and antioxidant enzymes. And we have also derived there are some results of the histochemistry analysis related to the oxidative stress, antioxidant enzymes, and these are some findings which we have discussed, and now come to the main mechanism. This is the mechanism which we have derived for this advantage. That how calcium takes the help from the boric acid and the endogenous nitric oxide to control the copper-induced oxidation stress management. So overall, what is the gist of this study? That calcium is very much effective if any plant is any field is suffering from the copper nanoparticle uh, because of high contamination of copper nanoparticle toxicity, and we spray the calcium nanoparticle, or we provide in the form of calcium fertilizer to the plant system, it can easily alleviate the toxicity of the copper nanoparticle in the agriculture field. So this is the overall mechanism which we have derived, and it's a conclusion which I have discussed with you. Is now the third component, last component of my lecture. Nanoparticle can take in the environment. So in the previous two components we have discussed, because the nanoparticle they are toxic, and if they are toxic, how we can manage? Nobody can claim in all over the globe that any component is very beneficial for the plant system. Yeah, any or for the any organism. Different organism we have differently with the elements or with the components which we are providing to the agriculture system, right? So although nanoparticles they are beneficial, but at a certain level, those dependent application is very important. It is not universally accepted that if you have this much amount is very beneficial for all the plant system or for all the organisms, because we have to be very careful about not only the plant system as well as the microorganism or other our environmental ecosystem. If anything is not very much helpful for the other ecosystem, it will be helpful for the plant system. It is not worth to apply. Okay. So that's why we have discussed in our previous slides that there are some nanoparticles, they may be toxic at a certain level, and if they are toxic, how we will manage their toxicity? Because they are toxic at very small amount, because they are nanoparticles, because their surface to volume ratio is very high as compared to the bulk material. So they are very much toxic. So how we can manage this? So we have discussed two components, toxicity and management. Now we will discuss about if nanoparticles they are very nanoparticles are very beneficial. So what are their benefits? So and I have already discussed that there are two major components, abiotic and biotic stress. They are two big issues in all over the globe, which our agriculture is suffering from very long duration of time. That we have not yet a sufficient solution, a permanent solution to control the abiotic and biotic stress. That's why we are we are also looking towards that if we have some component or some kind of material which is able to control the plant the abiotic stress. So nanoparticle may be one of them. Nanoparticle can control the abiotic stress in plants. So this is a new route for plant utility against the abiotic stress. So I will not go to the detail. We come to the main part. Yeah. And this is the first paper, silicon nanoparticle. We have synthesized the silicon nanoparticle, and we have taken chromium toxicity. Chromium is one of the abiotic stress. Abiotic stress include heavy metal stress, gout, salinity, and some other stress. Abiotic is where organism, living system is not involved. That's why they are known as abiotic stress. आप remove कर दीजिए बचेगा biotic stress. Biotic stress में where organism, any living system is involved, right? So under abiotic stress is heavy metal stress. Chromium is one of the guys and one of the heavy metal. Chromium is also comes in the heavy metal abiotic stress. So we have checked silicon nanoparticle and chromium hydroxide, and we have found that silicon nanoparticle is very much effective even at the very low amount. Isothermal theory. This is studies from FDP, plant physiology biochemistry, and these are some key findings that how silica is able to increase the photosynthesis, how it is very much efficacious to control the oxidative stress, how it is able to increase the growth, and how it is able to regulate the antioxidant hub, antioxidant machinery system. Antioxidants, they are also very important component in the plant system, and during stress period they may be high or they may be upregulated or downregulated. Generally they upregulated in the stress condition, but if plant is suffering from some toxic, very toxic material like you can say arsenic toxicity. Arsenic is very toxic. When plant feel the arsenic toxicity, so antioxidant machinery will downregulate. Means system will purely collapse, and plant will experience when plant is experiencing arsenic toxicity. So in some extent, plant the antioxidant machinery may be upregulated, or in some extent, plant antioxidant machinery may be downregulated. So here we can see this is the growth data. Here we can see, yes, here you can see that this is the control one. Green, you can see that SOD and GR, all these are increasing because they are supporting the plants. These are some materials. These are some data which we have reported, and here you can see that the study suggests four mechanisms by which silicon nanoparticle control the chromium toxicity, the decreased accumulation of chromium, reduction in upregulation of means when we apply the silicon, it it generally reduce the upregulation of chromium. It upregulates the antioxidant enzyme, and it also upregulates the nutrient availability. Silicon is overall toxic chromium. This is another study which is for the plant cells. Silicon nanoparticle more efficiently eliminate arsenic toxicity than silicon. In previous slide, we have discussed that silicon is very much able to control the abiotic distance. Now we have decided we have to check whether which form is very much silicon or this nanoparticle. Of course, silicon nanoparticle is very much effective because nanoparticle they are more efficacious. They are the volume and surface tension is very high. That's why silicon nanoparticle is more efficacious, more efficient, more able to control the arsenic process. So in this study, we have taken two different cultivars, and one is hybrid, and we have checked. We have found that silicon is nanoparticle is very plant system. Arsenic toxicity. So here we can see the conclusion that nanoparticle. In the previous slide, we have discussed that nanoparticles they are toxic and how we can manage the toxicity. Here we can see that some nanoparticles like silicon and zinc nanoparticles they are very difficult to control that. These are some conclusions of this. Now this is the again one of the other abiotic distance, that is UVB, ultraviolet radiation. This is also comes under the abiotic distance. So we have discussed the heavy metal stress. Now we come to the abiotic. Somebody can ask whether it is only effective against the heavy metal or it is effective some other abiotic stress. So that's why you confirm whether nanoparticles they are effective only in heavy metal stress or any other abiotic stress. We have taken the ultraviolet radiation, and we have found that silicon nanoparticle is very effective. And we have also compared with the silicon, its bulk material, because people can ask me why we need to synthesize nanoparticle. If silica is very big, is already reported, so we can easily utilize the silicon. But when we apply the silicon, it will require a very large amount, right? And we can, and if we will sensitize in the form of silicon, we will require a less amount of the silica, and we can apply it in the agricultural field, and we can control the environment. So in this study, this is also published in the, and this is very reputed journal, and so there is a plant biologist who referred to publish in plant journals. And these are some key findings we have discussed, that how these are some structural analysis. We have cut the sections. We have seen that how they are affecting silica and silica nanoparticle as well as the ultraviolet radiation. We have seen that here ultraviolet enhanced and ambient ultraviolet radiation. We can see that how they can damage the cells of the plant and as well as the chlorophyll system. Here we can ambient analysis. They have totally collapsed the chlorophyll, right? So here we can see that how they are damaging the plant system and how silica and particles they are protect the plant system. These are some antioxidant enzyme activity and photosynthesis analysis, and you see that the silica and particles they are effective against ultraviolet radiation, and both forms they are very effective, but silica nanoparticle is very effective as compared to silicon. So instead of using the silicon, we can utilize the silica nanoparticle to protect the ultraviolet radiation, right? This is another study published in Journal of Biotechnology, where we have again applied the synergistic action of silica nanoparticle and in low reactive cases the elimination of chromium process. So we have applied some inorganic acid, which is another form of the oxygen.